Now, related to some potential negative issues, another important aspect is that in this interaction between human and technology, of course, personal information security is a major limit. So here I just want to point out some interesting information that 60% of people seem to choose not to install an app if they have some issues or uncertainties related to personal information. So that's a big number. Therefore, when you develop a solution which will be distributed through different applications that exist or that you might build yourself, or you have to take into account these issues related to personal information security, not just go quickly over them. It is important to give the due thought about it. Another point is related to how useful is the network, the personal learning network on Twitter, for example, to different people. Well, this study looked at two types of individuals that are employees in a company. Thinking like this: okay, let's see what kind of individual is more creative in our company. And they discovered that those that have more diverse personal network on Twitter are more creative. Some people are in networks that actually follow each other, like in a circle. So they live a bit more in a cultural bubble, if you want to call it like that, or they tend to reinforce each other's idea or ideas. In a more diverse network, in which I do not necessarily follow exactly the people that are following me, I get all kind of different information, surprising stuff, that may help me much better in being creative. So you see, the structure of your personal learning network matters a lot. Another point is, how can you use these social medias, and for example Twitter? Well, in that company you can function as an idea scout, just to look outside that organization for new ideas. Somebody else might be an idea connector, somebody that is very good at assimilating, connecting the dots between these different bits of information to generate new solutions. So you can study for yourself this table here, but these are two roles. Different personalities may fit for different roles, of course. So it's up to you to identify that and to choose. In the next slide, I want to give a brief overview of the science itself, how it is applied in the daily life. Well, the most important network of science is the so-called web of science, in which different databases are interconnected. And this is where, for example, an article is being given an impact factor based on the number of citations that it receives from other studies. If you look for Wikipedia, Web of Science, you understand more about that. But if you want to understand how science works and how these learning networks equivalents are among experts, for example, this is the good place to start, the Web of Science. And you can contrast this a bit with the technology trends. That's a different way of looking at what is happening in science and technology. But both of them are major. The thing is, science is very cooperative, and the purpose here is just to find the truth, not to create value on the market, or not directly. The purpose is to clarify things. Technology trends are especially based on what they can do. That means what problems they can solve, and that is on markets. So the philosophy behind technology trends is a bit different. But it's good to have both of those in mind. That is, in the previous lesson we talked a bit more about technology trends. So here is the counterpart in science. And a nice map of global scientific cooperation was recently published, really a few days ago, by Nature, one of the major scientific journals in the world. And you see that because of the size and the role of science and technology in their own development, the United States is basically at the center of it, with strong connections with big and with industrialized countries in Europe, Asia. So you see there China, Australia, Japan, Germany, United Kingdom, France, and so on, and the rest of the world. It's a good platform to understand a bit some metrics of science. So if you go on that link, you can find more. But I just wanted to show how this can be mapped to. Now, the second purpose of this lesson is related to the role of computer models. And for that, I want to take you back a bit to the idea of knowledge management. And what we need to address is the management gaps that exist between information and knowledge on one hand, and between knowledge and action on the other hand. This is why we talk about knowledge action models and the role of computer models. Now, when we model things, we have to start with data, how we generate data. And if at point A on this slide I show you again this data, information, knowledge, action, result issue, at point B or section B, I show you a typical web-based sensor network architecture. If somebody collects data about pollution in a city, it is related to that. It involves also internet and so on. This is how it looks like. But then at point C, things become a bit more complicated. How you build a model. And you see that first and foremost, you need to start with a conceptual model, and then to generate an executable model, and then you will update it in time as many times as necessary, and then you obtain results, update requirements, and so on. Stimulant is related to the demonstration of it and validation of the model itself. I let you think more about these arrows, but what I want to say is that when you look at this point C, modeling and simulation fundamentals, you see how interrelated things are, and how many things you have to do in the same time. So that's part of the issue you have to deal with. In the next slide I give an example, and I believe I mentioned this to you already. It is based on the concept of urban sustainability nexus, that is the fundamental interaction and interdependency that exists between landscape, transport, energy and water in a city. This then is used to build a bigger model called Sustainable Community Reference Model, which is a holistic model. And this is composed of different submodels and sub-submodels. I don't give here the details. But what I want to give is some keywords related to methods. One is agent-based modeling, and I'm going to give some examples in the next slides. And then optimization, cellular automata, input-output, genetic algorithms, and so on. These keywords are only useful for you if you need and want to search for some approaches in modeling. So another example is an agent-based model. Now, these so-called agent-based models and agent-based modeling approaches are now very popular. They were very much restricted to academic and research domains, but now they become more practical because they're very flexible. You can apply them to solve different types of problems, and you can represent different issues in an abstract way that you can then model. Here I show an illustration of the business process and the views of different agents on the business. For example, in the business process, a given individual may only be concerned about the relation between operations and sales, for example. Another individual between research and development and investments, and so on. But the entire business incorporates many things. So how do you model all these correlations? Well, this is a knowledge map, basically, and a mind map that shows these relations, and you start from there. On the right hand side, then you see what this can mean in practice, and it's related to model design and parameterization, establishment of the parameters in the model, what data you need and the calibration of those parameters and the data, screening, evaluation, running, updates, and so on. This diagram, I only give it here to impress you. Joking, half. But it's just to show that you can develop it more and more. It becomes a protocol of action. If this is a situation, you do like that. If it's above this number, you take this way, and so on. And it uses the details that needs to be there. You can do something like that for yourself. And if you want to understand more, click on this link and you will get more. Now, by the end, I want to synthesize a bit the role of computer models, and we'll talk about some other details in the next and last lesson. But for the moment, you have to remember these 5 main points. That in the world of big data in which we are now, we cannot rely only on computing capacity. Actually, we need smart approaches, we need qualitative approaches to be able to understand what is going on. And this means modeling, knowledge maps, and so on. Then these models are only as useful as the assumptions that you take there. That means in a model I make all kind of assumptions, like if situation A happens, I go this way. If situation B happens, I go this way. But before that I have to define situation A and B and C eventually, and so on. So I have to understand that what I model here may not cover everything. So I have to define carefully all the components of the model. If something is not right, the model gives wrong results or difficult results. Third point, computer models are simply attempts to represent the reality, so that you can automate different actions of calculations or generation of different options. But the world is dynamic, new information, new methods appear all the time. So by the time you finish a computer model, which took you, for example, a year, let's say, many things already happened, so your model is outdated already. So what is the purpose of it? What is the purpose of even doing it? Well, just remember that versatility of the model is a must in it. You just have to have enough flexibility in the model so that when something new arrives, you can assimilate it into the model, so that you update it and it's still good. A model is good if it can evolve in time, not just being a photography of the situation of a given moment. The fourth point, the purpose of any model is to get insights, okay, not data. Because data, you can generate a lot of data, but if they are generated through different methods, for different purposes and so on, you cannot understand how the data is connected, so you don't understand the value of that data ultimately. You need you need a model to help you treat this data, to give you better insights, better understanding, and help you have ideas about how to approach different things. So it's not the numbers, it's the insight. Even though everybody knows the numbers are impressive, you know, they give this air of seriousness. Yes, but the insight is actually what is the serious stuff there. Data are just subordinated to this purpose. And finally, and as a corollary of all this, you need to maintain yourself with the models that you use on the right track. Okay, it's not a matter of understanding what happens. It's a matter of keeping you on an equilibrium and on the right track. But it is very costly to have all this modeling and difficult to manage. So you need to make some trade-offs. Practice tells us that it's better to be about right than to be precisely wrong. I'm saying that also as a manager, also as an analytical chemist. I'm that also. It's very easy to just throw some numbers into a big machine, they give you some simulations and say, oh, this is impressive. But if something was wrong with the assumptions or with the treatment of data, you are very precise, but you are wrong. Why invest so much? It's much more important to make a very balanced and well thought distribution of resources and organization of action, so that you in the end stay on the right track as much as possible, and after that as precise as possible. So therefore, better to be about right than precisely wrong. Again, for this lesson I don't have supplementary readings, but I count on you checking the links that I gave you inside the slides. I think these are useful for you. Thank you.